Hi, in this video, I will be doing examples of set operations, more complicated operations with the union, intersection, the complement, and the difference of sets. So these sets are on page 68. The universal set is going to be the counting numbers from 1 through 10. Set A is going to be the even numbers, the odd numbers from 1 through 9. Set B is going to be the counting numbers from 1 through 6, and set C is going to be 2, 4, 6, 7, 8. So perform the indicated operations. The first one is A union the empty set, but the empty set has no elements, so if you put together set A and the empty set, you're going to get again set A. The intersection of two sets is a set of elements that are common to both sets. If the empty set has no elements, it cannot have anything in common with any other set. On the other hand, everything that is in set A is already in the universal set, and repetition doesn't increase the number of elements. So A union the universal set is going to be again set A. And the only elements in common that are common to both A and the universal set are going to be the elements in A. So everything that is in A is already in the universal set. Actually, the first one was the universal set. Number 7 was the universal set, because the elements of A are already there, and the elements that are common to both A and the universal set are the elements of A. When doing other operations, the order of operation is important. So we need to do parentheses first. Okay, so number 10, actually, I'll need to cut that. I'm just going to copy number 10. So number 10, we want to find A complement, intersection, B union, C complement. So I'm copying this problem again. And we're going to do parentheses first. Well, we need to find the complements. We need to find the complements. The complement of A, if A is a set of odd numbers, A complement is going to be the set of even numbers. So that's going to be 2, 4, 6, 8, and 10. And B complement is going to be the set of elements in the universal set that are not in C. Actually, I'm looking for C complement, not B complement, but C complement. Those are going to be the sets involved in this operation. So C complement is going to be the elements of the universal set that are not in C. And those are 1, 3, 5, 9, and 10. Okay, so now we're going to do parentheses first. We are going to start by finding B union C complement. And B is a set of positive integers from 1 through 6. So B union C complement is going to be 1, 2, 3, 4, 5, 6. And we also need to include, if we're taking the union, we need to also include 9 and 10. So A intersection B union C complement is going to be the elements that are both in A complement and B union C complement. And those are what? Those are 2, 4, 6, and 10. So that's number 10. And number 12, that involves the difference of two sets. On number 12, we need to find A minus B union C. So again, parentheses first, we need to find first B union C. The elements that are common to both B and C, not both, that are in B or C or both. And those are the positive integers from 1 through 6 with the 7 and 8. So B union C is going to be every counting number up to 8. Those are the elements that are in either set or both sets. So A minus B union C. Those are the elements of A that are not in B union C. And A consists of the elements 1, 3, 5, 7, and 9. So the only element of A that is not in the union of B and C is 9. Remember that A was the set of odd integers between 1 and 9. So that's one example. The next one, these are examples with Venn diagrams. We're going to do number 26. We are going to represent the set using a Venn diagram. It's in the same page, page 68. So there's that, and we're doing number 26. So that's A union B minus C. Okay, so we're going to use a Venn diagram. We have a Venn diagram with 3 sets. So this is initially what we have. We have a Venn diagram with the universal set is the rectangle, and then we have sets A, B, and C. So we are going to call these sets A, B, and C. Okay, so we're going to do this in parts. We're going to do this by parts. We are going to find A union B first. Start with whatever is within parentheses. So A union B is going to be this region consisting of A, whatever is in A, or B, or both. So once we do that, we need to remove the part from C. So this little portion that is from C, we're going to remove that. So then A union B minus C, we need to remove the part from C. So again, we're going to draw the next Venn diagram. So we had sets A, B, and C. And the part from A union B that doesn't contain C is going to be only this part. So this is A union B minus C. So that's one example. In the other example, they are giving us the Venn diagram, and we need to use set notation to describe the region. So everything is on page 68. The region they are giving us is this. I'm doing number 32. There are actually 2 correct answers to this. So there are 2 correct answers. And I mean, it's up to you. Whatever answer you find, they are both correct. There is no answer that is better than the other one. And I don't see one that is simpler than the other one. So the region on the left is A minus B, and the region of the right is B minus A. So we can take the union of that. A minus B, union B minus A. So that's one answer. Or the other answer that is correct, we have the union, but we are removing the overlapping region. That is, we are removing the intersection. So another way to see it is that this is A union B minus A intersection B. So both answers are correct. And I'll do one example with counting the elements of a set. So again, it's everything from the same page. Okay, so we have a Venn diagram, and the numbers inside the regions are the number of elements in each region. And I'll do a couple of those. For example, the number of elements of A union B. So that's number 42. The number of elements of A union B. So A union B is going to be all this region. And what we do is add the number of elements in each region. So the number of elements in A union B is going to be 4. Or let's start from left to right. That's going to be 6 plus 4 plus 13 plus 9 plus 11 plus 7. So add all this together. So that's what? 6 plus 4 is 10. 10 plus 13 is 23. 23, 32, 43. So that's 50. So the union of A and B has 50 elements. And the last one, it's number 44, where we found the number of elements of A minus C. So A minus C is going to be the set of elements of A that are not in C. So it's going to be only this region. So that is going to be A minus C. So we just add 6 plus 4. So A minus C has 10 elements. So these were the examples that I wanted to show you. Thank you for listening.